Okay, this is section 1.4 for pre-calc. Here we're shifting, reflecting, stretching, and shrinking graphs. Now this goes right along with stuff you actually did this back in algebra, you did this, and it goes right along when we were graphing trig. All of the same rules apply about left, right, stretching, and shrinking. So the first thing, these are called translations. That's where you just move it around. If you look at the general equation here of any function, so in the parentheses was x, is the x minus h. The h always tells you whether you go left or right. And you always do kind of the opposite of the way it looks because of the minus sign. So if this said x plus 2, that would be left 2. If it said x minus 4, that would be right 4. The number outside the parentheses by itself is plus k. That tells you the vertical. So that's up and down. And that's just like it looks. If that says plus 1, it's up 1. If that says minus 5, it's down 5. So if we had this graph, if I said, here's my standard graph, y equals f of x, what kind of shifting is going on here? We always start from the inside. So x minus 2 means we're going to go right 2. This plus 3 out here means we're going up 3. Or this one here, again, start inside the parentheses. That x plus 1 says we're going to shift that whole graph left 1. The minus 2 says we're going to shift that graph down 2. So those are translations. That's just shifting left and right and up and down. Then you have transformations. There's 3 things involved here. First, the most common thing is to have a number multiplied out front. Now that's a vertical stretch. Whatever that number is, you're going to multiply all of the y coordinates by that number. So if that number out front is a 2, you would double all the y coordinates. So if a graph was at 1, 1, now it would be at 1, 2. If there was a point at 3, 5, now it would be 3, 10. If that number is a fraction less than 1, then it's shrunk because it's going to be smaller. So if their point was at 2, 6, and that was a 1/2, now it would move down to 2, 3. That's what it means here. That the absolute value is greater than 1. In other words, if it's a number bigger than 1, whether it's positive or negative, doesn't matter. It's stretched vertically by that number. If that number in there is smaller than 1, so if it's between -1 and 1, so it's a fraction in there, then it's shrunk vertically by that amount. And then if that number is negative, it's flipped vertically. So you change the sign of all the y coordinates. So if it says y equals negative x, that means this is flipped vertically. Or a lot of times they'll call that inverted. So it just flips the whole thing over. Now if the negative is inside with the x, notice the difference here. Here it's on the outside. Here it's inside the parentheses with the x. Anything inside the parentheses is horizontal. So this one is flipped horizontally. So it's flipped across the x-axis. I'm sorry, across the y-axis, I misspoke. So it's flipped sideways. Like this one, there's a 2 out front. So this one is stretched vertically by 2. So if it asks you to describe it, that's what you'd say, stretched vertically by 2. Now, if the number is inside, like it is here, this should have said 1 over b here. Anything inside here is horizontal. So this is stretched or shrunk horizontally. Now, just like before with the plus or minus, we have to kind of think opposite. Here, if there's a whole number in here with the x, that's actually shrunk horizontally by 1 over whatever that number is. So if there's a 2 there, that would be shrunk horizontally by 1/2. So you would take every x coordinate and take half of it. So it says here by 1 over b. So it's stretched. So if that's a fraction, again, it's the opposite. So if that's a 1/3, that means it's actually stretched horizontally by 3. So you would multiply every x coordinate by 3. And then if it's negative like we had here, it's flipped horizontally. So like here, there's a 3 inside there here. So this one is shrunk horizontally by 1/3. So you take 1/3 of every x. Okay. Now usually these come in combinations. It doesn't always matter, but it's good to always start from inside the parentheses and work your way out. So like here, if you start inside x minus 4, means right 4. This 2 out front, so it's out front, so it's stretched vertically by 2. And that means you take all the y coordinates and take them times 2. And then it's got a 3 out front. Well, that's just like a plus 3 in the back. So that is up 3. So that's the 3 things that would be happening there. So here you would take a parabola, because that's a squared graph. You take a normal parabola, you'd shift it right 4. You'd stretch it vertically by 2, so you take all the y coordinates and double them, and then you move the whole graph up 3. Here, this is a square root graph, so you know it's like looks like the half of a sideways parabola. So you start inside the bracket here. We have a plus 3, so that would be left 3. There's a 1/2 out here, so that means shrunk vertically by 1/2, and that means you take all the y coordinates by half. Also, it's got a negative, so this is inverted, so you would change the sign of all the y coordinates, and then after you do all that, then you move down 1. And it could be very important that you go in order a lot of times. All right, so now these sample problems, we're going to use those things. So they give you first a parent graph. So here we have f of x equals x squared. Well, that's a parabola that's 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. So that's what that graph looks like right there. So it's that parabola. Now we're going to shift it. So this one, we're going to go right 3 and down 2. So if we're graphing that, we're going to go right 3. So we take like this point, go right 3, down 2. Take this point here, right 3, down 2. Or this point here, right 3, down 2. Same way here, right 3, down 2. Right 3, down 2. So that graph looks like this one. Now this next one, in here we have a plus 1, so that's left 1. It's got a negative out front, so it's inverted. And then a negative 3 out here, that's down 3. So that's the 3 things we're doing there. So again, we start from here, we go left 1, now inverted, so this is right on the x-axis, so inverted doesn't affect it, and then down 3. Or this point here, we would go left 1, inverted puts it at a negative 1, and then down 3. Or this point here, left 1, inverted it takes a positive 1 to a negative 1, and then down 3. So this graph is going to look like this. All right, this was an absolute value graph. If you remember, an absolute value graph looks like this. Now, the first thing we have here is, looks like left 3 and up 2. So we're going to do that to all the points. Like this vertex, left 3, up 2. This point here, left 3, up 2. Left 3, up 2. So that graph looks like this. Now this one here, we're going to, if we start, we're going to go left 1. The 2 means we're going to be stretched vertically by 2, so we're going to double all the y's, and then we're going to move down 4. So here we're at 0, 0, we're going to go left 1. We're stretched vertically by 2. Well, here the y coordinate is 0, so stretching it leaves it at 0. And then we're going down 4. Or this point here, left 1. Stretched vertically by 2. Well, it's at 1 now. If we double it, that puts us at 2, and then down 4. Or this point here, left 1, stretched vertically by 2. So 1 times 2 is 2, and then down 4. Or even if we did one more, like this point here that's at 3, 3, left 1, Stretch vertically by 2 puts us at 6, and then down 4. So this graph is going to look like this. If you can tell by looking at that, it looked like we stretched it vertically by 2. Right, this next one is a square root graph. A square root graph, if you plug in some numbers 0, 0, the square root of 1 is 1, the square root of 4 is 2. So a square root graph looks like that. Let's see, this first one looks like we're going left 3, then we're going to be shrunk vertically by a half, and then down 1. So we take this point, go left 3, take half of the y, it's going to stay at 0, and then down 1. Or here, left 3, 1, 2, 3, half of the y, well it's at 1, so a half would put it at 1/2, and then down 1. This point at 4, 2, we go left 3, half of 2 is 1, and then down 1. So this is going to look like that. Do you see that we moved it left 3? Do you see it's shrunk vertically by a half and down 1? Now this last one, they gave us a graph here, and then sometimes it'll be that way. They'll be given a graph. So this is the graph of f of x right here. Just the lines connecting those 4 points. Now here, this looks like right 1 and up 2. So we just take those 4 points and go right 1, up 2, right 1, up 2, right 1, up 2, right 1, up 2. So that looks like the same graph, just made those 2 shifts. This one here, that 1/2 out front means shrunk vertically by 1/2, and the -1 means inverted. So this point right here, the y coordinate's 1, we take it by 1/2, puts us at 1/2, and inverted puts us at -1/2. This one here, the y coordinate is 2, half of that is 1, inverted is -1. Here the y coordinate is 3, half of that is 1.5, inverted is -1.5. Oh, I'm doing the wrong point. Sorry, I was using the red one instead. Sorry, let's go back from the start. So here we're at 1, we're at -1, half of that's a -1/2, inverted is a +1/2. Sorry about those extra points. I was looking at my red graph instead of my dark graph. Here the y is 0, so half of 0 is 0, inverted it stays right there. This point right here is at 1, half of that's 1/2, inverted is a -1/2. Here y is 2, half of that is 1, inverted is -1. So this graph, if I get the right points now, would look like that. So again, that's graphing. Just follow through and go step by step through the thing.